Perfect, perfect. All right. So I'll restart. My name is Hamza. I work in the network threat detection at Meta, and I'm here to talk about Zeek at Meta in 2024. And we'll cover a bit of the scale at which we deploy Zeek. We'll talk about how we enrich these logs and some detections that we build on it. So yeah, for a primer, I want to give you some insight into what kind of networks we want visibility into, the infrastructure that we use to deploy NSM, and all the other steps that we do to make Zeek log so much better, and some detections. And there's also a bonus section on how we've managed to deploy Zeek in a virtual machine. So yeah, let's start with the COP network. But before that, a background on why NSM is important. Network security monitoring has been a pretty high priority security project for over a decade at Meta. Because network context, network forensics is crucial for security investigation, and it paints a whole picture. Like everyone who's worked in network forensics basically knows that the network doesn't lie. All the packets you see on the wire are the way it is, and those communications don't lie. So, given that we have a heterogeneous set of hardware or assets, we don't have a one size fits all EDR. So we definitely need network context to fill in the gaps and paint the whole picture when we're investigating incidents. But yeah, this is our enterprise network. We call it Corp internally. So this is our Corp network. This is the network that brings all the metamates together. Yes, we go by metamates. The metamates work out of offices, or if they're remote, they VPN into the enterprise network. And we also have some dev testing labs in our enterprise network, and we have a whole bunch of VLANs and network devices which mesh the network together. And like any other company, we need to host essential services like DNS and mail and storage in our enterprise network. We also have some security scanners, and we also have to give some vendor access to the CORP network. So the God network as a whole is very, very heterogeneous. That's the point which I'm trying to get here. And it almost looks like a cookie which you've put too many nuts or chocolate chips into, and it's a pretty big thing. But yeah, the COP network needs connectivity to our prod network and the internet to become a success, right? Like every metamate, every engineer who needs to work on products like Instagram, WhatsApp, Quest needs to go into prod. That's the network that serves our users. And at the same time, the engineers also need to access the internet to debug solutions, to access Stack Overflow and whatnot. So we need to link these networks, and that's a given. And that's exactly where our team comes in. That's exactly where we deploy our Zeek instances, our NSM architecture between the links. So we want network visibility between the boundaries of Corp and all the other networks that it connects to, and that's what we tap. But yeah, easier said than done. I can draw three circles on a picture and tap them, but in reality, our CORP network, our physical CORP network, is much, much, much bigger, and it takes a whole enterprise network engineering team to keep it alive, to keep it healthy. So kudos to them. But all in all, we have four CORP data centers across NORAM. We have four CORP points of presence across EMEA and APAC, and this connects over 70 Meta offices, and that is the insight that we need. That is where we want to deploy NSM. So we want to monitor everything that's coming into Corp and leaving Corp. So that being said, we tap about 6,400 gig links at our Corp DCs, and we tap so many more links at our Corp POP. So at peak utilization, if the entire Corp backbone is saturated, NSM at Meta spans over 10 terabytes per second, which means that we need to capture and monitor 10 terabits per second of network bandwidth. And to give you an insight on what that bandwidth looks like at 10 terabits per second, you can stream 400 4K copies of Dune simultaneously. And that in my head, just like the scale at which we run our enterprise network itself, sometimes amazes me. But yeah, what we've spoken about so far is the need for network visibility in our enterprise network, in our Corp network, because the threat surface is much wider and we need more eyes into the network. And we need to somehow tap and monitor 10 terabits per second on network bandwidth. But yeah, let's talk about the infrastructure that we use for this. Pretty standard infrastructure, industry-wide recommendation that once you exceed a certain bandwidth threshold, you need passive optical taps, and that's exactly what we do. Our NSM infrastructure consists of three major components. We have the optical taps, we have packet brokers, and we have sensor hosts. So the packet brokers provide fault tolerance, redundancy, load balancing, and they collect all the captured packets, all the captured traffic, and distribute that across our sensors, our Zeek and Suricata sensors. So again, this forum requires no introduction to Zeek. This was a previous slide which I had, but it's always I always feel proud about presenting Zeek to other security investigators, other security orgs at Meta, because it tells them that it introduces them to the power of Zeek, about what the kind of visibility that Zeek gives us. But yeah, a Zeek sensor, these are the specs for one standard Zeek sensor. We have about 200 gigs of memory. We have about 40 cores to utilize. We use standard commodity NICs. And we have 250 of these hosts. We use 250 sensors to tap the 10 terabits per second of traffic. That means that at peak utilization, every sensor is approximately seeing 40 gigabits per second. And realistically, like since all the numbers I've spoken about so far are the links themselves, the capacity links, we don't operate a core backbone at capacity, which means that realistically, we only want each sensor, we've designed it in such a way that we only want each sensor to see about 12.5 gigabits per second of traffic. This is mainly because we don't need that much. And the other thing being is that we start to see memory issues once we start pushing more than 12.5 gigahertz per second of network bandwidth into the sensor. All right. I love graphs. I like pretty graphs, especially with color. So this is exactly that. This is the bits per second of traffic which is being received by each sensor. These are about 180 lines across time, and this is in the last, I want to say, 2 weeks or so. And you can see that at times each sensor even sees up to 20 gigabits per second, and that's the kind of traffic we process at our NSM sensors. All right, so this does not come, we need to do some extreme optimizations, and thanks to past Zeek Week talks about extreme performance tuning, I've basically studied this and gone through these optimizations in order to make sure that Zeek produces accurate logs and does its best to keep connection context. We need to turn off a lot of NIC optimizations, such as offloading, checksum offloading, TCP segmentation offloading, those kind of things. We need to generate a symmetric hash key so that the NIC as well as the kernel is able to load balance the captured traffic, the captured packets almost equally across 18 queues, 18 receive queues that we use, which are mapped to R queues, which are mapped to Zeek workers. And the one thing which I love is now Zeek LTS comes with AF packet built in. Like this was not the case, I want to say a year or 2 years ago. And I remember going through it and installing AF packet manually and doing a lot of stuff manually. But now I love it that Zeek is maturing, and these features are fantastic. But yeah, I mentioned we have 18 Zeek workers, 18 Zeek worker threads, and across 250 sensors, which gives us 4,500 Zeek workers at any given time. But yeah, this is the big number. This is the number that we produce across the 10 terabits per second of traffic, and 250 sensors. We are generating 16.15 billion Zeek connection logs per day. This is an average number, and you can see the graph itself. So this is some massive scale. This is a massive network data set that we generate for our enterprise network, or when we tap and we implement network security monitoring at the boundaries of our enterprise network. But yeah, 16 billion logs. That's a lot. But yeah, talking more about these numbers, we have 16 billion connections per day, 16 billion unique community IDs. We've enabled community ID across all our Zeek conn logs. We have about 187 kilobytes of data transferred across each connection, so an average, and each connection lasts an average 169. So this is an offset. We have some connections which are long running, and we have some really short connections as well. And God knows how many VR headsets. But yeah, bring it all together. We manage all of these servers using Chef, which implements package upgrades and makes sure that our sensors are working with the latest and greatest Zeek version. It configures Zeek scripts, figures out how to aggregate syslog, how to wake up syslog and do all the thing. We tail all of the log files that we generate using Zeek and send them to our Hive storage, to like our data warehouse, you can say. So we're storing about 1 terabyte per day, and we do have a massive retention for these Zeek logs, which spans over 4 years. So we store over 1.4 petabytes of Zeek logs, yeah, at Meta. But yeah, moving on to log enrichment. So quick recap. We've tapped 10 terabits per second of traffic across 250 sensors. We've generated 16 billion logs, and Zeek logs are very handy. They give us this immense context. But something that I also want to call out is Meta has a diverse and enormous IP space. IP addresses and IP subnets are all over the place. We have so many network segments, so many ACL rules which go all over the place. So that creates a challenge when we look at just IP addresses or the connections, the 5-tuple that Zeek creates. So once again, the Zeek logs that we primarily ingest today are these four. We love conn.log. DNS gives us beautiful insight about who our endpoints are trying to talk to. We have HTTP logs and some SSL logs as well. So basic conn.log, we care about the 5-tuple, the connection duration, the bytes transmitted, mainly connection duration and bytes transmitted, because that allows us to generate or create these volumetric detections, which we'll talk about later. But yeah, this is what a sample of our conn.log looks. We have the time, we have source IP, source port, destination port, and a protocol. So the real good stuff, the reason why we use Zeek here. So let's take an example, taking a bit slower here. We pick one connection, and I give you this connection, and as a security incident responder, I tell you that this connection is definitely sus. There's something off with it. And looking just at the Zeek raw logs, this is what we generate, right? The very first question anyone's going to ask me is, who is this? Who does this IP belong to? Who was using this IP at that given timestamp? Was it a user, a host name, a service? What was this IP assigned to? And if you can see, we also have a destination port of 53, and the protocol is UDP, which means that this is DNS, which means that was the destination IP our DNS server? Was it an external DNS server? How does this work? Like, tell us more about the DNS server itself. So that's okay. We can now pivot into DNS logs to get more context, to figure out what is the domain that was requested, or the response that was found, the answer that got back. But let's go one step further and say that the DNS request was made for a known domain ISC. Like, we know that that domain is malicious and it's an indicator of compromise, which means that we need to investigate this alert more. But that's where the investigation stops, right? That's where the investigation needs a concept of identity, which means that all our Zeek logs, all our connection logs, all the IP addresses that we know are talking to each other need a concept of identity attached to this. And this is a very big effort or a massive project that our team took up, which means that if you have this IP address, can you tell me which user, which hostname, which service, who was using this IP address? And it's much easier said than done again, given that Meta loves to make everything in-house. And again, Meta loves Zeek because Zeek is open source and we can operate and we can deploy our own instances independently, which is fantastic, which allows us to scale at the level that we need it. But the same issue creeps into this concept of identity. We need the identity of the IP address, and we explored multiple solutions here. We wanted to do reverse DNS lookups, which was not feasible, not performant enough. We wanted to pull in DHCP logs to see that who was assigned this IP at what DHCP lease time and that kind of stuff. But turns out DHCP logs are fragmented across network segments. There are way too many network segments and VLANs across our enterprise network, and bringing DHCP logs was not feasible. Not feasible at least at the scale that we need. So it's not as simple as this is an IP address and this is the identity. here you go. You found the holy grail. That doesn't technically work at Meta. And although we have an excellent asset management and inventory setup, it's not federated. Again, we have pockets of these asset management. So bringing it all together was this massive effort that my team took up, and we spent over a year investing into this thing called enriched corp Zeek logs, which means that all we want to know is that IP address and who was that IP address. Like, give us more information about, give us the meta, but the metadata. So what we ended up doing is that we brought in a lot of these source tables. Anything which had IP address on it, we brought it in just to study and tell us that, okay, now we have these Zeek logs, we want more. We want to know more about these Zeek logs, the connection logs. So we process our connection logs, we take it through these steps of data enrichment, we take it through multiple steps of the data enrichment pipeline, which is just glorified table joins. But at the end of the day, this is what we end up with. We have ACL zones, we have IP address subnets, we have host names and on-calls and services. Everything that we can trace back to that IP address with the concept, any concept of identity is beautiful because now we can leverage Zeek logs for so much more. We can build detections on Zeek logs and then investigate, and it can paint the entire network picture easily. But yeah, going back to our earlier example where we took the source and destination IP address, but after we go through this, go through this enrichment step, the final product looks something like this. We instead of source IP, now we have source host. The source host could be an employee laptop, it could be an enterprise server, it could be a production server, it could be anything. So at that connection that we spoke about was basically user three, who was in corp. So we also get this declaration about domain, where when we say domain, we mean the bigger pictures that we saw, the bigger networks that we saw. We just want to know whether this IP address belongs to prod, whether this IP address belongs to corp, whether it does not belong to meta at all. So it's non-FB or non-meta. It's the internet out there. So we want this concept of domain, which allows us to do a lot of cool volumetric analysis. But at the same time, we know that, okay, so coming back to this, we have user three whose IP address is in corp, whose host is in corp. They're reaching this. So we also bring in source subnets. So which subnet was the host connected to? And this gives us kind of an inkling or some kind of insight into the location of the connection as well, because the way we model our subnets is through location. So we can tell that this user three was located at the HKG office, and they made a DNS resolution to our corp resolve. All right, so quick recap. 10 terabits per second of traffic across 250 sensors, generating 16 billion hosts, going through a lot of enrichment, going through a lot of context gathering. And the context gathering pipeline itself takes, like, we want to do near real-time Zeek logs. We want access to near real-time Zeek logs, and that could be fantastic. But given that we want to go enrichment, that enrichment pipeline takes about 4 hours. So yeah, we're almost there. We want to make it faster, but since we have other external source dependencies, we can't go as fast as we want. But at the end of the day, what we're left with is these 16 billion connection logs across our enterprise network, which are enriched and tell us exactly what subnet, what source host, what destination host, what protocol. And then if you pivot into the other Zeek logs like DNS and HTTP SSL, you can get SNIs, you can get domain names, you can get answers and whatnot. But using this entire massive network data set, this massive network collection, I would say, we're ready to build Zeek detections. So yeah, building detections on Zeek logs. Now, this is a novel approach, I would say. We started doing this back in 2020, I want to say, like back then, because Zeek back then was the Zeek logs themselves are perfect for security incident network forensics investigations, but we want to do something different. So we started building detections on Zeek logs themselves. And it's basic stats right here. So we want to baseline and profile the network connections that we see across our enterprise network. That is, this IP address is talking to this IP address, and they've been speaking for quite some time now. They usually talk a few megabytes per day, or the connection duration between these two IP addresses more or less remains under 10 seconds. So that kind of profiling is what we do. And that allows us to build these thresholds, these moving window look back thresholds. And using those thresholds, we can create these volumetric spike alerts, which means that this IP address has now sent out massive amounts of data to that IP address within our enterprise setup. And that means something could be off. So what we do is we create these alerts and we escalate them to our SIM. But not just that, like the logs, since they're enriched, we also can build signature-based detections on them, like atomic signature-based detection. So and then this other effort that we also took up was we were mapping TTPs back to network behaviors to build detections on these logs. All right. So this was one of the first detections we built. This is an example right here where we call it Zeek def to corp exfil. The idea behind this was that all the engineers who have access to the development environment, are they are they transferring large amounts of data back to their employee laptop? So the gist right there was large volumes of data being transferred from a dev host to a corp host. What we do is we sum up all the bytes that we see between those domains that we spoke about, like from prod to corp, and then we baseline what is novel. Like this employee usually just transfers a few megabytes, or this connection only lasts a few seconds, but suddenly we've seen 50 gigabytes of data, being transferred from a dev host to a corp host, which could indicate which could indicate attempts at exfiltration, whether it's sensitive user data or code base or intellectual property. We want to know what's happening, right? And we record these spikes and we record these anomalies and escalate it to our in-house SIM. The other detection that we've built is a little more, the other example which I want to take here is a little more signature-based, a little more atomic in nature, where we have a bunch of these storage servers, a bunch of these network file storage or some kind of shared storage servers in our enterprise network, in the corp network. And these storage servers are allowed to reach out to the internet for updates and whatnot, right? But the thing is that we know exactly which external domains these servers reach out to. And that's a known good list of destinations, which means that we have an allow list of what they can reach out to. Any other access to the internet could basically be indication of breach or indication of data exfiltration. So very straightforward. Given that we have that visibility using Zeek and all the enrichment, that we can say that this IP address belongs to a storage server or a storage subnet, we can build a detection like this. So we took two examples, and this is a detection win that we've been talking about for 3 years now. But this was one of the first detection wins, which validated a lot of our efforts, which gave us the confidence that we were on the right track, building these detections based on Zeek logs, right? Because back then it wasn't that known. But the gist of this was that using DNS logs, we were trying to identify this TTP called subdomain enumeration, where a threat actor may encode information in the subdomain, and the top level domain basically belongs to the attacker's infrastructure or has been registered by the attacker. And our Zeek logs, a detection back then fired, and we got an NSM alert saying that, hey, this IP address has resolved way too many subdomains to the domain life in the DMZ. And this seemed very strange. It almost gave us the red alarm feeling that, hey, something's happening. Should we have a breach? Let's all wake up. Turns out it was an internal red team, and we caught the red team using using an open source malware framework called Sliver, which had established a C2 channel over DNS. So again, perfect validation that we needed, that enriched Zeek logs, building detections on enriched Zeek logs was the way to go. And now we've expanded our suite of detections. We do so much more with Zeek logs, which is fantastic. I wish I get to talk more about this. But yeah, other than the basic Zeek detections, like the proactive Zeek detections that we model and speculate, Zeek logs and connection logs are fantastic for retroactive investigations and threat hunts. Like we said, we have some long-term storage for Zeek logs, which means that spanning across 4 years, we can actually go back in time and see whether we've had breaches or we've seen a known 0-day or a CVE pop up in our environment. And this network data set, this enriched network data set, is fantastic for that. So we can paint the whole picture, like I spoke about earlier, and we can close out incidents and these investigations much, much, much faster. We also have Zeek DNS logs, which are beautiful to understand the blast radius of incidents, like domain incidents and whatnot. So yeah, what else do we have? All right, so stepping out of security, Zeek is fantastic for security, but the Zeek logs themselves. So now what I have become is a Zeek evangelist in my team as well as in my org, where I go to other network engineers and I tell them, hey, do you want to use these logs to optimize your network? Like I'm actively getting people to use this data set because while we have fantastic value in these Zeek logs and enriched Zeek logs from a security point of view, they also allow us to study traffic patterns and understand our load balancing policies and make them more efficient. We can troubleshoot network connections like, hey, I see this IP reach out to that IP, but I don't see the ping back. Why is that? The way Zeek has been positioned, the way we tap a network, it allows us to actually even see, one-off connections. Like suppose that connection was dropped by an ACL rule or something like that, right? Most recently, we've also had this data set been used for proxy validations that for all the endpoints that we have in this given network segment, are they using the proxy that they're supposed to? If they're not, then these logs, the NSM logs, give us the insight that, hey, the proxy has not been set up correctly. We also had some compliance checks. We had some compliance folk reach out to us and ask us that, hey, are there people in are there people in MetaMates in the Corp network, are they accessing sensitive information, sensitive user data, sensitive information in prod? And we want to know whether these specific endpoints are being touched or not. So we can also validate some compliance there. And most recently, I've also had to ask about, can you tell me how much bandwidth my VLAN is consuming? Like, what are the total amount of bytes? Like, how much bandwidth my VLAN has consumed, which is fantastic. So, all right. So we've spoken about the massive scale. We've spoken about 10 terabits per second of bandwidth, 250 sensors, 16 billion logs, enriched logs. What's next? We're just getting started. We've only been able to tap into the four big logs, that's DNS, SSL, HTTP, and conn. We want more. We want so much more. Given that Zeek is so flexible, is so customizable, and we're running our own deployment, we're running our own thing on open source LTS Zeek, gives us the power to integrate everything and anything that we need, right? So the new hotness is JAR 4 server client fingerprinting, which I think, yeah, last week we implemented that. We are officially doing JAR 4 fingerprinting for all of the connections that we spoke about. Uh, RDP, remote desktop protocol. We do not like remote desktop agents and remote desktop solutions in our enterprise network, which means that any kind of RDP logs coming in and out of the network are bad logs, are basically a red flag. We want to explore, we want to create a more tight coupling between Zeek and Suricata. We have Suricata running on the same captured traffic that Zeek sees. So Suricata we have a bunch of subscriptions, we have a bunch of alerts and rule sets which have already been deployed. But there's a fantastic part about community ID, that using the community ID, the 5-tuple hash, we can actually go in and out. So which means that we can get context, we can get Zeek network context for any alert that Suricata fires. And lastly, like this is the thing which I'm trying to push for, is to make Zeek more location aware, to know that, okay, Zeek, this instance of Zeek or this NSM server has been deployed in a sensitive geographical area, and that's why we need to escalate those logs with higher priority or something like that. And most recently, I've been asked the question, and the question which I've asked my teammates as well is, let's leverage AI. Let's leverage the new hotness, which is, can we actually get an LLM to hold network context? Like if you show an LLM our Zeek logs, our enriched Zeek logs, what would the LLM say? Like, can give us insights. But yeah, that's pretty much Zeek at Meta. This is how we're using Zeek to protect our enterprise network. A bonus section right here. We've also successfully deployed Zeek in virtual machines. And when I say this is more like a very specific facilities network example. The facilities network is the network which brings together a lot of our ICS devices, our industrial control system devices, which powers our data centers. So within our data centers, we have these IP-enabled HVAC systems and power distribution systems and air conditioning systems, which are technically on the network. And we've seen an uptick in the supply chain threat surface right there. So we have a fantastic team, IDC Security, which does this, which consumes the Zeek logs and they build detections and give us visibility in this. Quick on this, the Zeek VM is pretty out there. The way we implement this solution is using rack switches, using the span solution that I showed up there, where we get the rack switches to mirror a copy of the traffic and aggregate them at the VM. And across 100 DC buildings that we've deployed the Zeek VM, we've now collected about 1 billion connection logs, which is good. The call out here is Modbus. There's so much Modbus out there. There's so much backnet out there. And again, given that there are so many more plugins that we can just drop into Zeek, we love that. We love that we can get so much more insight into our network using Zeek. But yeah, that's been my time. Thank you so much for having me. Again, I'd be remiss to not thank my entire team and all the people who helped me maintain this infrastructure, who helped me design this, who helped me troubleshoot it across the entire thing. Like I said, this is a massive effort since our corp network itself is physically large and logically large. So thank you, everyone. And thank you so much for having me for the Zeek webinar series. Yeah, let's do questions.
Thank you so much, Hamza, for this amazing presentation. Of course, I personally learned a lot, and I'm pretty sure our audience who was listening to this webinar have pretty good insights, and the detections that you have shared are pretty insightful as well. So thank you so much again for this webinar. We do have one question in the queue. It's from Tim Nolan, and I think it is regarding the site where the slide where you were doing the conn.log enrichment. And the question is, are you using the input framework for enrichment, or are you finding post-logging enrichment more useful? If so, why?
Yes, I haven't completely explored input framework, and yes, I'm aware that we can make our Zeek sensors more aware about our domains and our enrichment right there at the sensor level. But given that most of our Zeek sensors are already at memory peak and they're so distributed, it's very hard to get that entire data set of IP address to identity mapping mapped into one Zeek sensor because things are changing constantly. That's why we find way more value in post-processing the Zeek logs and building detections out of that. While we'd love to have Zeek tell us exactly that instead of a source IP, just give us a source host, that'd be fantastic. That'd be a dream come true. But so far, we haven't been able to scale that solution at the scale. Yeah.
Cool, thank you. I think we have a hand raised by Christian, and we have a couple more questions in the queue. So let me see if I can allow Christian to talk.
All right, can you guys hear me?
Yep.
Thank you, Fatima. Okay, awesome. Thank you so much for this talk. This is fantastic. I predict this will become a highlight on our YouTube channel pretty quickly, and your enthusiasm is contagious. I wanted to ask you, given the really high number of nodes in your Zeek cluster, are you technically running this as one cluster, or is it sort of a set of independent ones?
We rely on the packet broker layer to do some load balancing, but it's basically every sensor runs its own Zeek instance, and every sensor basically we go into cluster mode, but then we leverage the threads themselves. So we don't have independent Zeek sensor workers and then Zeek distributors itself. So we've done this a little differently, but yeah, I'm still optimizing. I'm still learning more about infrastructure. So the more I learn, the better I can deploy this.
Yeah, got it. I have so many follow-up questions. Maybe we should talk some other time. Thank you very much.
Absolutely.
Very cool. Thank you.
All right, thanks, Christian. We do have a couple more hands up, so I'll just ask, okay, so Fulton, you should be able to unmute and talk. All right. Oh, okay, perfect. Fulton, are you speaking? We cannot hear you for some reason, so.
When you do your placement for your sensors, considering your bandwidth requirements and your critical mission requirements, how many sensors do you have, and then where do you put them? And I have another question follow up.
Could you repeat the first part of the question? Like the volume was just coming in.
So you only have so much bandwidth for your sensors, and you have a critical mission to evaluate. So how do you architect your placement, and how many sensors do you guys use for your enterprise?
So at currently we have 250 Zeek sensors and 250 Suricata sensors, and this number is just growing. I'm provisioning new racks almost every other week because the compliance, the policy here that we're going with is that anything that connects that is part of enterprise network, like every time enterprise network reaches out to the broad network of the internet, every time we turn up a new link, it has to have NSM on it. It has to go through Zeek and Suricata. And that's why, yeah, while we have set that threshold that every sensor should only see 12.5 gigabits per second of traffic, we just scale out horizontally.
Thank you. Next question. You mentioned AI LLM models identifying alerts, but you also mentioned JAF4 fingerprinting. Which one do you find more valuable?
We haven't started analyzing our Java fingerprinting. That's definitely going to be something that we'll pick up later this year or early next year. With the LLM stuff, that is just a shot in the dark. At this point, it's too early to tell whether the LLM can actually understand the crux of a network context. Like, we'd have to do way more optimizations. I'm looking for industry solutions to come up, which we can adopt. But yeah, we don't have the very strong incentive to use LLMs for network context today.
Okay, hey, that's what I was thinking. The random forest tree models we're used to are not going to predict them. Again, not going to predict an accurate alert. Thank you. Appreciate it.
Awesome. Thank you so much. And we do have two more questions on the chat. So the first question is, are the Zeek scripts open sourced? Like, how do you do the statistics, or is it not done by Zeek scripts? So that was one question.
Zeek scripts. We have developed just a few debugging Zeek scripts to understand what the sensor is doing. We haven't created end-to-end Zeek scripts, and if I do end up going down that route, once I get like some more resources to invest in this, I would love to open source anything that we build out there. But right now, we're a consumer of the open source community. We haven't been able to contribute as much.
Cool. Well, thank you. And then the last question we have on chat is there any feature you wished was part of open source Zeek built in?
Every time I have a wish list, it somehow just appears. I really wanted AF packet, and it just showed up. I wanted community ID built in, and the new LTSS community ID built in. It's one command away. So I love the thing, but yeah, that's a really good question. I'm gonna have to think about it. Like, what could I offload onto the sensor itself? I know we have some efficient subnetting which we could do. But I'm gonna have to explore this for myself before I can give a valid answer.
That sounds That sounds pretty reasonable. And you do know that we have a Zeek Slack channel, so I'm just going to shamelessly plug that in. That if you want to have a new feature, we have like different channels out there, and then there is like a core development team channel as well. So you can always ask any kind of feature, or if you want to just like discuss some kind of detection scripts, whatnot. We have like a whole bunch of community out there, and I'm pretty sure people who are attending this call might also be part of the Slack channel. And if because of the time constraint, if we don't get through all the questions, they would love to hang out there and chat with you if you're still there.
Yeah,
So
I'm part of the Zeek Slack channel. The issue that we've had for the longest time is that we'd built Zeek from source and then distributed across a sensor. And it's only very recently that we've been able to directly take the open source builds that you guys have. And that's unlocked a lot. Like now we're not worried about package wrapping, package maintenance. We're just consuming what you guys give us and then building on top of that, which is fantastic.
awesome. Yeah, absolutely. So, all right. I think we have gone through all the questions, and I don't see any other raised hands from the attendees. So then let's wrap it up. Actually, you know what? Wait, we do have one more hand. So, and we're almost at the top of the hour, but we can just take that in real quick.
Hey.
Go ahead, Colton.
Thank you. I have one more question. You guys went from regular Zeek logs to enriched connection Zeek logs. Could you explain the difference and why you made the change?
So the main reason is we can't do much with the source IP. Our IP space, like I mentioned, is massive, and we have a /32 IPv6 subnet assigned to us, which is too much. Mapping this back itself, the logs that actually contain that IP to identity mapping are fragmented, and then bringing that in gives us that essential power that we're not talking IP addresses. It's basically the question of why we use DNS. We don't like IP addresses, we like domains, and that's exactly why that.
Thank you so much for answering all my questions and your wonderful presentation, everyone.
All right, I think we're almost 1 minute past our time. So again, thank you so much, Hamza, for this great presentation. And we look forward to many more presentations coming from Meta, especially you and all the cool detections and whatever you guys are doing with Zeek. That is pretty cool. So thank you again for the time. And thank you so much for attending all the attendees this webinar. It was great. So I think we can just wrap it up. All right. Thank you so much, guys. Take care and see you guys in the next webinar.